Have you had your furnace tuned up for fall and winter? All the many mechanical components inside your furnace work together like a symphony orchestra to create the beautiful sound of hot air blowing out of your home's vents. That'll be music to your ears when the air is chilly. And take that comforting warmth for granted though we may, if just one of those instruments hits a sour note, that mellifluous melody could quickly give way to the sound of chattering teeth, pipes bursting, and grousing spouses. You likely won't even notice something's funny with your furnace until it's too late, and you're in need of an emergency repair. As a dedicated DIYer, I normally advocate for homeowners tending to their own household maintenance obligations. My motto is, if I can do it, you can do it. But if I can't do it, and you can't do it, somebody's got to do it. That's why I'm calling in reinforcements. This is my HomeServe homie Randy. He's a bona fide HomeServe HVAC tech, and he's here to show us what a furnace tune-up comprises and what we should expect in terms of time and cost. So Randy, what level of difficulty would you rate this job, and is this the sort of thing that the average homeowner could or should undertake themselves?
I'd put it somewhere between an 8 and a 10. I'm going to be getting into opening gas, which can be dangerous if you're not trained professionally. We're going to be looking at electricity, somewhere in that range.
When and how often should homeowners be having a furnace tune-up done?
You should be getting it done in the off seasons, typically just before the season starts. And how often? Every year. It should be done yearly. A lot of safety issues can arise, such as carbon monoxide poisoning, and we're checking that on every single tune-up.
Okay, now that we have all that background information, would you mind showing us how a furnace tune-up is done in real time?
Absolutely, it's what I'm here for.
Okay, well, let's get to it then, Maestro.
So one of the first things I like to do is check the thermostat. And we've made sure that it's turned up. We want to make sure that the equipment's actually working before we touch anything. We'll open this panel here, and we should see the flames going away. So we've confirmed the system is working properly before we've touched it. We're going to shut the power off to proceed with the tune-up. Check the filter and see if it needs to be replaced. In most cases, we have to replace them. They're usually 90-day filters. Some people wait till 6 months. And you can see definitely in there's some buildup. This should be a nice white, just like the cardboard here. And always remember, the arrow goes towards the equipment. We're going to be shutting off the gas valve. I'm going to turn on our manometer and make sure we're reading 0. I'm going to turn the gas back on so I can get a pressure reading of what's coming in the house. And right now we're sitting at about 6 1/4. So when the gas valve is energized, this is going to drop. We dropped quite a bit on this one. This might actually be a situation where we have the gas company come out and check the regulator. These are the small little safety things that we do on a tune-up that you wouldn't necessarily be able to do as a homeowner. Because I'm actually going to shut the gas off again to make sure that the board signals that the flame is gone, which it has done. It has shut down. Perfect. Now I'm going to take the manifold plug out. On this side, we want about 3.5 inches of water column. So in this case, we're running just at about 3.5 inches in high fire. So the gas pressures are looking good on the manifold side. We are definitely going to see if we can get the customer to get National Grid or whoever their gas service supplier is out here to check the regulator. All right, next I'm going to pull the flame sensor, which is a safety device to tell the system, yes, the gas has been ignited and it's not dumping raw fuel. And here you can see there's a little bit of buildup on it. If this gets too dirty, it won't sense flame, and that can be #1 cause for no heats. Next, I'm going to see if I can clean up the ground on the electrodes, because this is a spark ignition, not a hot surface ignition. Next, I'm going to pull the condensate trap. This is a 96% furnace, and it creates condensation in the middle of the winter. Any of these little trap ways, if they get clogged up, condensate will block up into the heat exchanger, and then you'll have no heat. Before we reinsert it, we want to prime the trap, and that's just getting water back inside there so it can do its job. All right, so now the condensate's cleaned. I'm going to check the vacuum, how much vacuum the inducer is pulling. We have these pressure switches up here. There's 2 of them here because this is a 2-stage system. So for high fire, the switch is rated for 0.7. We shouldn't be even close to 0.7. It should be much higher. And we're pulling about 1.55, almost double, which is perfect. Next, we're going to check the capacitor on the blower. We're looking for anywhere from plus or minus 10%, and we got 9.5. That's pretty close. So this capacitor is good. And next, we're going to do an amp draw on the motor. It's almost impossible to see what the rating is on this furnace. It's tucked way in the back. You'd have to remove the whole assembly to get to it. So generally, as a rule of thumb, we look for 10 or less. And we're right at about 6 amps. That's perfectly fine. Next, we're just going to do a normal check on all the wires to make sure they're all connected, they're all nice and tight. Everything feels pretty good. All right, next we're going to check the flame signal. We're going to turn the system on. Once the system fires up and the gas ignites, we should see a change here on the meter, and we want to see at least 1 microamp. Here we can see we got 2.5, so that's a good flame signal. So for this next test, doing a combustion test, we want to make sure our blower door is on. We don't want to create any sort of negative pressure that can affect our readings. So for a furnace, we get a 2-part test. When it first fires up, our O2 will drop, and when the blower comes on, the O2 should move. The CO should be under 100 parts per million, and in a perfect world, it should be single digits, teens, maybe 20s. All right, and here are the same results in high fire. So you can see the numbers have come down drastically. I would say everything with this system seems to be okay. And one of the final things that I like to do is just wipe everything down in the cabinet, make it as clean as possible.
Oh, what'd that take? Like a half hour, 45 minutes?
About 45 minutes on this one, yeah.
It's exhausting.
It is exhausting. A lot of work goes into it.
You're telling me? So Randy, besides these annual tune-ups, what's the most important thing a homeowner can do to keep their furnace in top working order?
Stick with keeping up with the filter replacements and annual maintenance by a professional. That's the best thing you can do to keep it running as long as possible.
In terms of the filter replacements, what percentage of homeowners do you think actually replace their filters as often as necessary?
I'd say 60% probably know they have to, but the actual number, there's no way to measure it. I've been to some that are 3 years old still in a furnace.
Let's get down to brass tacks, Randy. How much is this going to cost me?
It really depends. Based on the time this video was shot, the geographical location and the area you live in, you can look at the description below to see the national average cost right now.
So anything else we need to know about this?
No, outside of replacing filters and going outside occasionally if you have a direct vent, making sure the vent is clear from snow if you live in snowy areas. Those would be the only other items a homeowner should really be doing.
Now that you've seen all that, homeowners, what do you think? DIY dilemma or a problem for the pros? Let us know in the comments. Can I have that back now, please?
Hey.